Welcome to Easy Mathematics, and I'm the video to the JEE Advanced series. Today I want to talk about question 4 from sheet 2 from the year 2020. And I changed the task a little bit. So let's see. Given trace of A and trace of A cubed of a 2 by 2 matrix, determine the determinant of A. So this is the task, and in the original task there were given certain values like trace of A is 3 and trace of A cubed something else, but I don't want to use these values. I want to talk about how you can start this task. It's a beautiful task in my opinion, and before we start, you read carefully, and we know that we have to find a determinant given some special values of traces. And before we start, we should think about what can help us, and of course we should know about some basic properties of the trace. What is a trace? What is the behavior of a trace? And given some traces, and we want to determine the determinant, we should think about the relation between trace and the determinant. Hidden hints from the answers. Do we have hidden hints from the answers? The task could also be find the relation between the determinant and the trace. It's like the same question. So we should think carefully about these points. And first of all, here we talk about a 2 by 2 matrix, and we should know that the characteristic polynomial of a 2 by 2 matrix can be written as x squared minus trace of A times x plus determinant of A. And this is our relationship between determinant and trace via the characteristic polynomial. And also, what is very important here is, if we evaluate this polynomial at the matrix A, we get 0. So in other words, A is a 0 of the characteristic polynomial. It's a property you should know about. If not, please make sure you check this out. And for the trace, it's a very obvious property. The trace is linear, so trace of r times A plus r times B is r times trace A plus s times trace B. So the trace of a sum is the sum of the traces. This is it follows immediately from the definition of matrix addition. So this is not difficult. This is very obvious. And how can we solve it? We will use this property. This is the basic key, and this is the key of this task. And how can we use it? So first of all, we know that if we plug in A in the characteristic polynomial, we get 0. So we have A squared minus trace of A times A plus determinant of A times I, where I is the identity matrix, okay? Because the determinant of A is a scalar, and we need here the identity matrix, okay? Think about that. And then what we do is we multiplicate this equation by the matrix A to get a cube. So 0 times A is 0, A squared times A is A cubed, a times a is a squared. Trace a is a scalar, okay? Make sure don't mix that up. Trace a is a scalar. It's a real number, not a matrix, okay? And also I times a is a, and the determinant of a is also a real number. It's not a matrix, so everything goes well here. And now we consider the trace on both sides. So trace 0 equals the trace of this cubic matrix term. Then we use the linearity of the trace. So what do we get? Trace of a cubed minus trace of a times trace of a squared, so plus determinant of a times trace of a. Okay, this is the linearity of the trace. For trace a, we have trace a cubed, but we have no knowledge about trace of a squared. So how can we use this? The trace of a squared, we use the characteristic polynomial here, and we solve this for a squared. We get trace of a times a minus determinant of a times I. This is here. So you can pause the video and think about that step carefully. And now we use the linearity of the trace again for this term, and we get, yeah, this expression here. Okay, so this is the linearity of the trace. Now we know that trace of the identity matrix is 2 because yeah, it's a 2 by 2 matrix, and the trace is the sum of the diagonal elements. So we are left with this. Now the trace times trace times trace is trace cubed, and here we have 2 times trace. This part here, trace a times determinant of a trace a plus determinant a trace a is 3 times determinant trace a times determinant a. 3 times trace a times determinant a. Alright, and now we can solve for the determinant, because everything what is given is here, and finally we find determinant of a is trace cubed minus trace of a cubed over 3 times trace of a. Alright, yeah, and that's all. We have found the determinant in terms of the trace of a and the trace of a cubed. Well, that's all. Thanks for watching. See you next time. Bye bye.